This video will concentrate on our future planning. The main part of it explained at the middle of the motivation video, actually in the 28 minutes from its beginning, but we will repeat it shortly now. We will start by gathering books, notebooks, and eventually all the material starting from elementary school and going up. All this knowledge will be inserted in their best and most fitted forms, as we mentioned before, and also connected and screwed into its right place in our system. And that's how we'll evolve and spread. Now I want to emphasize and remind you, even though it was already mentioned, how flexible everything is in this program, and that any problem which might float to the surface can be solved. Let's see an example for it. Suppose we created a brackets or parentheses operation. This operation is searching and selecting which of the operations that are inside of it should run, and all that is done by some set of rules and priorities, just like a rules for cars in a junction, to decide who's got the preference to drive among them. So that's how this operation would control the runnings. Here's a simple calculation. First we attend the left and only brackets. In it we attend the multiplication. So 7 times 5 is 35. Now we go back to attend the brackets. This time there's only the plus to run. 6 plus 35 is 41. Now we attend the most left multiplication. 3 times 41 is 123. Again we attend the most left multiplication, this time starting with the left side of it. 8 times 4 is 32. Now we do the 32 times 2, which is 64. Now we do the left subtraction. 123 minus 64 is 59. And the only thing left is 59 plus 4, which is 63. It is all good, but what if this parenthesis operation was made only on natural numbers, and now after we continued we discovered that there are also integer numbers and even real numbers? How did this happen, you might ask? It may occur from many reasons, like the plan was to start develop from the lowest level to the higher, so you cannot always know and anticipate what changes are to come. Another reason, it wasn't relevant at the time it was planned, and many other possible reasons. Now what can we do? How we handle this? Well, there are some possible ways. First, we create a new operation, separated one, that will contain all these new possibilities, or we'll create many likewise operations that each will act specifically for each possibility of those, one for natural numbers, one for integer numbers, one for fractions, and one for the real numbers. And then we can unite all these operations into one operation that will check the type of the numbers and then decide which of those operations should run. Another way is by updating the current operation, meaning changing it, that now it includes all those new possibilities too. This example was simple, but this principle is good for all the complex operations in higher education, so let's not disregard it. Here you can see one of the many stuff that you can do with this program. You can see a set of formulas, an example of formulas, equations that you can work on. What I mean is that you can develop them, you can set an examples, you can do homeworks, do some works in school, answer, build stuff, anything you want, using like for example you have the platform, and in the left you can see the set of operations. So you can gather as many operations as you like for using them in your work. and anything you like algebraic operations, differential operations, integral, calculus, geometric, trigonometric operation, and any operations that you want of any type and any grade or class. Here you will see an example of search operation. Here's a collection of items or properties. You can put here any number and any kind of properties, and as you can see, it has a similar format like any other search utilities that you know. Like for example, searching in your computer for files, or in any typical search engine like Google, Yahoo, and so on. In this example, we are looking for things that their name starting with Astro, their ID saved is in the range of 140 to 180. They contain the word physics in their description, and they have the property math with the value of equations, meaning we're looking in the things that are mathematical equations. And here we change the name, the property name, to the expression magnetic and 5 more characters, exactly 5 more characters. But this is just one of the possible search operations. We will have also searches inside maps, diagrams, pictures, formulas, search trees, and of course simple text. Comparing to Google search, we will have much more options, better options to look for. We will use Boolean operations like AND or NOT, or the operation OR. It will be much more sophisticated than the simple advanced option in Google, as you can see now. We haven't shown you the actual search operation in runtime because in this demo most of the operations are only simple arithmetic and very similar, so it doesn't really effective for searching, meaning there isn't much to search for. All of this was one of the future plans. Now we are going to see a live demonstration of many of the principles we were talking about in the earlier videos. We start by seeing formulas inside our platform. Now we can see the same formulas, but this time using arrows to show you all the directions of the development, how the formulas evolve from each other. As you can see, everything here was miniaturized using the factor property in our platform. So we did a zoom out to see the map from a distance, to see as many formulas together as possible. Now you see the sources of information we used to build our map. And these sources are actually relatively clear and good, built up well. And yet each of them still is not enough to understand everything completely. So you have to dig up and complete these holes, and that's what we did. In addition, needed to say before we come back to our platform that this is just a visual example, only for presentation, so you won't see any running operations here. Also, you can see that there are skipped calculations, and all this made by writing, while in our platform everything is automatic and precise, and you slide in everything to know how it's done to the bone. Here's the example of a document where are skipped stages of calculations, and the person might not know how it was done, how he got to this formula. So he searches and searches, and if he's lucky and smart enough, he finds a clue of how it's done in some place. In our platform you can see exactly every stage you want at any level, so you can expand the information that is hidden from you. So you can see the formula that we had trouble with. Now you can see all the formulas that we need to explain how we got to this formula. And if it's not enough, you can even get inside these formulas and get more information, and get more and more information, and dig inside it and slide and find all the information you need. So if, for example, you see some formula, you can open it up to its white state, for instance, and see that it contains one assumption. So anywhere you'll want to use this formula, you will know all its limitations and conditions, all its assumptions, and more. And this is one of the most important things in sciences. This is where mistakes are made. Also, as you can see, there can be many different details, like simple description, names, types of things, and so on. And now we open for you to see all the formulas that contain any kind of information. And it doesn't end here. All of these formulas can be added and inserted to stuff like classes, lectures, homeworks, essays, books, web pages like Wikipedia, and not only text stuff, but multimedia also, like pictures, videos, simulations, animations, and more. As we mentioned before, there will be conversions between units. It will be done using the appropriate operations in any formula or expression or a collection of those that we'll desire. But there are all sorts of more stuff we can do. Convert an equation or a whole development. We'll use the correct rules for it, like those tables you see. Again, all these operations are accurate and immediate, with all the help we need inside of them, and much faster than the usual writing on a paper method. Here's another example, not relevant to the conversion issue, but does relevant to the program. We'll have all the data there is about every chemical element, and one of the possible presentations for this information is when they gathered all together in the periodical table. And not only one, there are actually more than one arrangement possible, meaning more than one table. So all of those different tables and arrangements will be in our storage file, connected and linked accordingly in the right way.